Okay, in this video I'm going to explain how you can find displacement from a velocity time graph, and in the process we will derive the equation that kind of looks like it came out of nowhere, but you're going to see it makes perfect sense, that displacement is equal to initial velocity times your change in time plus half times acceleration times time squared. Okay, consider a plot where you're looking at the velocity of an object plotted against time. Now, you know that by definition, your velocity's average, the average velocity, is displacement divided by time. A simple rearrangement shows you that displacement is equal to velocity times time. Now consider this. If you have velocity here and time there, the product of the two, that is what you get when you multiply them, is equal to the velocity times time. But the product of the length and the width is also the area. So from there, we can infer that the area under a velocity time graph is equal to the displacement. The area under a velocity time graph is equal to your displacement. Now consider an object that's moving with some initial velocity. I'm going to call that VI. That's your initial velocity. However, it's accelerating, which means its velocity is constantly changing. And as that velocity changes, imagine it's increasing right up to this final velocity. So we still have time on this axis here, and our velocity increases from an initial value to a final value. The amount of time that it takes to increase its velocity is our change in time. We're going to call that delta t. Because the product of velocity and time gives you displacement, the displacement during this time interval is going to be the area under this graph. So how do I find that area? That's our initial velocity, that's our final velocity, and this is our change in time. We have a composite figure here. We have a rectangle and a triangle. The area under that rectangle is simply going to be, so let's call that area 1 and area 2. And the displacement is equal to area 1 plus area 2. So just reminding you, the displacement of an object is the area under the velocity time graph. And the area under this velocity time graph is composed of area 1, this rectangle, and area 2, this triangle. Area 1 is simply your initial velocity, because that's the height, and your time interval, delta t. So area 1 is VI delta t. Area 2 is, this is a triangle, so its area is half the base times the height. So it is 1/2. The height is final velocity minus initial velocity. And the base is delta t. Okay, now what is final velocity minus initial velocity, and how is it related to time? Well, consider the very definition of acceleration. Acceleration is the final velocity minus the initial velocity, that is, it's the change in velocity divided by the change in time. So that means the final velocity minus the initial velocity is equal to acceleration times time. See, I just multiply delta t up on both sides. So I can take my expression for area 2, and I can replace final velocity minus initial velocity with acceleration times time. So I've got area 2 is 1/2 of acceleration times time times time. Again, I replaced this with acceleration times time because acceleration is your change in velocity over time. So your change in velocity is acceleration times time. So when I put all that together, displacement is area 1 plus area 2. It is the initial velocity times your change in time plus 1/2 acceleration times your change in time times your change in time, which gives the familiar equation. Your displacement is your initial velocity times time plus 1/2 acceleration time squared.